Hello everyone, welcome back to my channel. This time we will going to learn about the remaining properties of the metals. Let us start the remaining chemical properties of the metal. This is the part 3 of metals and non-metals. So the contents are, we will going to learn about the reaction with hydrogen, that is formation of metal hydrides, formation of metal halides, formation of metal sulfides, and we will also learn about the displacement reaction. At last, we are going to solve some questions. So, what are metal hydrides? Hydrides are the compounds of hydrogen. How do metal reacts with hydrogen? Metal usually do not combine with hydrogen easily, but there are some metals like sodium and calcium, they form metal hydrides. The most reactive metals such as sodium, calcium react with hydrogen to form metal hydrides. But if we talk about magnesium and copper, they form hydrides with difficulty. So let us find out why some metal form hydrides easily and why some not. So why do metals do not show reaction with hydrogen easily? Metals and hydrogen both have a tendency to lose electron because hydrogen have one electron. So it has a valency of +1 like group 1 elements. So both have same nature of losing electron. Thus, metals do not combine with hydrogen easily. Since group 1 metals are highly electropositive, so they can form hydrides, but others do not. So this is the reason. Both have the same valency, so they have same chemical nature. Now what are metal halides? Halides are the compounds which are formed by the reaction of halogens. So let us see how do metal reacts with halogens. Group 17 elements in the periodic table, chlorine, fluorine, bromine, iodine, astatine, are known as halogens. They react readily with alkali and alkali earth metals to form salts. These salts are known as halide salts. The basic reaction of this is metal when react with halogen, they form metal halides. Let us take some example. Sodium react with chlorine to form sodium chloride. Iron react with chlorine to form iron chloride. Magnesium and copper also forms magnesium and copper chloride respectively. So this is the very common reaction and this reaction is feasible. That is this reaction formation of halide takes place readily. The reason being that metals are electropositive in nature, halides are electronegative in nature. So halogens being non-metal, they have a tendency to gain electron. Metals, they are electropositive in nature, they have a tendency to lose electron. So both have opposite nature. And due to this reason, the formation of halide salts is easy. They readily react. All these salts are ionic compound. These are formed through ionic bond. That is, sodium has given the electron and chlorine has accepted the electron. So this reaction takes place readily. Now let us talk about metal sulfides. Sulfides are the compounds of sulfur. How do metal reacts with sulfur? Metal easily reacts with sulfur to form metal sulfides. Sodium react with sulfur to form sodium sulfide. Magnesium react with sulfur to form magnesium sulfide. Iron, copper and zinc also show this reaction. So sulfur is usually regarded as an impurity. During metallurgical operation, we get minerals and from these minerals we need to extract the metal. So metal usually found in the combination of sulfur with the combination of sulfur in nature. So sulfur is generally regarded as an impurity and it is removed during the process of metallurgical operations by the process of roasting and calcination. Now let us learn about displacement reaction. How do metal displace other from its solution? Reactive metals can displace less reactive metals from their compounds in solution or in molten form. Now, how we can check the reactivity of metals now? We can check the reactivity of the metal by knowing the electrochemical series. In electrochemical series, metals are arranged in the order of high reactivity to low reactivity. That is, the most electropositive metals are present at the top, whereas the less electropositive metals are present at the bottom. So, which metal can displace the other? We can easily know by learning this reactivity series. For example, if we have two metals, for example, we have suppose zinc and we have a solution of iron. So uh, when we mix zinc with the solution of iron, then zinc will easily displace iron from its solution. Why? Because zinc is placed above the iron in the reactivity series. You can see here. So zinc is more reactive than iron. But vice versa cannot be happen. That is, iron cannot displace zinc from its solution. So by learning this activity series, you can easily know which metal is more reactive and which is less, or which metal can displace which metal from the solution. We have checked the reactivity of various metal with oxygen and water as well. So in all the reaction we have seen that the metals like sodium, potassium, magnesium, they readily react with oxygen, they readily react with water and with acids. But if we talk about the metal at the bottom of the reactivity series, for example, silver, platinum and gold, so they are inert to these reaction. So what is the reason? The reason is that they are less electropositive. Okay, so by learning this activity series, we can easily know the displacement of metal. Let us see some examples as well. So here you can see that zinc displaces copper from the copper sulfate solution. How? Because zinc is placed above the copper in reactivity series. That is, zinc is more reactive than copper. So here zinc can easily displace copper from its solution and can form zinc sulfate, as you can see here. Now second example, iron when react with copper sulfate, it form ferrous sulfate. That is, iron here can easily displace copper because iron is more reactive than copper. And in reactivity series also, you can check the position of all these metals. That is, iron is placed above the copper. So such type of questions can be asked in the paper. Now, learnings from the video. Let us solve some questions. What determine the activity of metals or reactivity of the metals? The electropositive nature defines the reactivity of metals. The metal which is more electropositive will react readily, whereas the metal which are less electropositive will react slowly. Now let us answer the second question. Name the metals which has very low melting point and can be melt with the heat of your palm. So potassium is the metal which has a very low melting point and can be kept in the palm and it will easily melt. We can also, in spite of sodium, we can also say lithium is also a metal which can be kept in the palm and it will melt with the heat of your palm. Alkali metals are generally soft and they have the low melting point. But we cannot keep sodium because sodium is most reactive. Now let us answer the third question. Can iron displace silver from silver nitrate solution? Yes, iron can easily displace silver from its solution. This is because silver is inert and it is placed at the bottom of the reactivity series. Now let us answer the fourth question. Can zinc displace iron from its solution? Yes, zinc can also displace iron from its solution because zinc is more reactive than iron. But yes, vice versa cannot be happen. That is, iron cannot displace zinc from its solution. This is because zinc is more reactive than iron. Now, can we arrange the following metals in decreasing order of their reactivity? Decreasing order means the most reactive metal should be kept first and the least reactive metal should be kept at the bottom. So, you can check the position of these metal in the reactivity series. You will find that metals like sodium, calcium, aluminium, they are the topmost metal, and metals like copper and zinc and copper will be placed at the bottom of the series. So you can check the reactivity series and you can get the answer of this question. You will get sodium first, then calcium, then magnesium, aluminium and then zinc, and at the last you will get the copper. So I think you have learned many things about the chemical properties of the metal. Thank you.